Okay, so supply and demand. When you have a game economy, we have producers which produce stuff, right? They are producing a certain amount of commodities or services or whatever. So each producer produces a certain amount of commodities. Pi of commodity. And we have consumers. And each consumer consumes, well, for example, Ci of commodity. Well, at least it wants to consume Ci of commodity. And we want to kind of match consumers and producers. So, for example, and sometimes producers can be consumers, and sometimes the produced amount depends on the consumed amount, right? Because, for example, if you have a factory which converts one commodity into another commodity, we have a certain producer. If it is not able to consume this amount, then it should produce less than a smaller amount of commodities than it could produce otherwise. But here is a tricky thing. For example, we can say that this is a commodity Cj. So we add the J, and let's just consider the production matrix. So we have, for example, producer Sir I. It consumes, well, for example, a certain vector of goods, right? It consumes commodity E, let's say, it consumes a certain vector of commodities. For example, it needs 1 point of this commodity, it consumes 2 points of this commodity, and so on. And when it's able to consume all of these commodities, it produces a new commodity. Let's say a commodity well, we can define production in various ways, but for simplicity, let's think of it as they can produce only one commodity. It's trivial to expand this system to the multiple commodities, but in most games, producers produce only one output. It makes a lot of computations simpler in practice, even if theoretically it's just the same thing. So it produces a certain, and let's say it produces a commodity output Y. And here we have, well, doesn't matter what exactly, 2. So each producer is could be defined as a very simple thing, right? It is a vector of inputs and a very simple vector of outputs, assuming that this vector of inputs is satisfied fully. So, and what we are actually doing during production is the following. We have a certain supply, right? Supply is generated by these vectors. But to now the supply, we want to know how well we have satisfied these inputs on the previous step, right? So if we need demand, if we want supply, we need satisfaction of demand. But to calculate satisfaction of demand, we already need supply and demand. So to calculate supply, we already need to know supply. And this is an issue because essentially it introduces a dependency of value on itself, right? We want to have supply which is which generates demand in a way so so satisfied demand generates again the same supply as we wanted. Well, there are many solutions to this issue. For example, we could just do a process like, well, let's start from nothing, right? And then we just iterate over and over until we converge to the values when, so for example, we have a certain vector of supply, supply vector, S. It shows how many goods are there in general on the market, how many goods were supplied. And we have a demand vector, D, which shows how many goods we have attempted to buy. From these vectors, we can calculate vectors of satisfaction, right? We need essentially, in the basic form, we need only demand satisfaction. Let's call it demand satisfaction vector. And it's easy to calculate it, usually. Demand satisfaction is just a minimum of 1 and supply divided by demand. Well, of course, there are obvious issues when demand is 0. It could be handled in many ways. I will explain these ways a bit later when introducing how we are working with supply and demand in Alice. But for now, this formula works well, almost everywhere, let's say like this. But now we can use this satisfaction of demand to recalculate supply, right? Because the production requires current satisfaction of demand. So let's say that this was supply 0, demand 0. We calculated this thing and got satisfaction of demand 0. Now we can again recalculate everything given this value with this vector and get supply 1, demand 1. Again recalculate demand, supply 1, satisfaction of demand. and again and again and again and again. And well, in most cases, at certain step, they just will stop changing. We get into the position when these values are stable, more or less stable. The further steps will change them in non-significant way. It means that we have already arrived at the point where we can say, well, yes, this is what we believe to be the supply and demand on this day, assuming that transactions happen at the same time. Well, this is a lot of operations. We in complex enough systems, we can't really estimate how many iterations we actually need to produce current day supply and demand. It could be 10, 2, or maybe 10,000. It's just impossible to predict without having any bounds on producers. We can resolve this issue in many ways. For example, one of the ways to resolve it is to match supply with it's to collect supply from the amount supplied on the previous day. So, for example, you have a certain day. Let's say this is day 0. On day 0, we have supplied, for example, a certain amount. Well, let's say we supplied a certain amount and we demanded a certain amount. For example, we can assume that at day -1, supply demand satisfaction is equal to, let's say, 1. And assuming this demand satisfaction, we can calculate day 0 supply and demand. Essentially, we are saying, okay, we have managed to buy a certain amount of goods yesterday, and now we are using them to produce new amount and demand a certain amount of goods to produce this amount of supply. Fine. It allows us to calculate new demand satisfaction. And then we know that at this day we have managed to satisfy this amount of demand. This amount of demand fits into next day supply and demand. It fits into demand satisfaction of day 1, and so on. Well, you can notice that essentially we are doing exactly the same thing, right, as there. But we are spreading this process over the time. We don't care about matching demand and supply in exact way. We are matching essentially supply of the previous day with demand of today. We have produced something yesterday, and now we can use this supplied amount to actually produce. We match this supplied amount with demand of the current day, and we manage to supply a new amount of goods. This kind of, well, it kind of reminds a conveyor belt where you have a conveyor which does every day exactly the same operation, right? Over and over. This is kind of a main way to make this process a lot of faster. So this is why A lot of games just calculate supply and demand satisfaction of the previous day, and then match it with the current day production to avoid this kind of interdependency. It allows you to make a game maybe, so if you need there 10,000 or maybe 1,000 iterations, this little trick allows you to make your game economy loop 1,000 times faster. So, but there are still some unknowns. How exactly we match supply and demand? So we can calculate, of course, this value in the simple way, but sometimes you can do different things. For example, in Victoria 2, they are doing a really strange process. You have all suppliers and producers ranked. So, for example, by nation. For example, this is producers. This is suppliers. This is nation 1, nation of rank 1. This is nation of rank 1 again. Then you have nation 2 of rank 2, which produces another amount and supplies, let's say, the not suppliers, of course, but consumers. Here you have nation of rank 1 of 2, nation of rank 3, and so on, so on, so on. In Victoria 2, the game does the following. So we have a certain amount of supply and demand on the previous day. We have producers. The first producer sells the first, and the first consumers consumes the first. So we have this first quantity of product produced amount delegated for consumer 1. Consumer 1 consumes the amount which is produced by the first ranked nation. They are matched directly like this. Then producer consumer 2 consumes what the first nation was not able to consume. And again, it is consumed by producer 1. Then you have nation 2 consuming from the nation of rank 2 among the producers, and so on and so on and so on. On the first sight, it looks like, well, a normal process. Well, it's not really obvious that this kind of thing is not really good on the first sight. But let's consider the picture in general. For example, when we have a certain supply-demand disbalance, which is really common in case of Victoria 2 price update. We have, for example, supplied amount like this, subdivided between nations. There are, for example, 4 main producers of iron or whatever else. Let's say this is iron production. Iron producers. And we have consumers of iron. and we want really a lot of iron. We need a railroad, we need steel, we need machine parts, and so on, so on, so on. So what does happen there? Again, we connect the top supplier with top consumer. Right? And then as we approach the end of supply, we can see that these two nations have demand satisfaction of 1. And then this nation is kind of, well, their demand satisfaction is 1/3. So the moment you pass through this border, you are experiencing a drop in your demand satisfaction immediately, which is not really good for your producers. And then the rest of the world have demand satisfaction of 0. They get nothing at all. And rank is a discrete thing, as we all know. For example, if these two nations switch their places, they immediately switch their demand satisfaction, sometimes in a really significant way. It introduces a lot of instability into the system. And of course, this system is just not fun or fair, because if you're playing this as these nations, they get nothing. They are losers. They get none of this produced iron. If they have no iron on their national markets, of course. And this situation is not good, because let's just try to play as Greece or something like this without exploiting the prestige. And try to play as a low ranking Greece is just awful. You can't build anything. You can't build unions. You can't build factories. You don't have access to any resources of the world market. It just doesn't feel really good or fair, because the score is such an arbitrary value that attaching ability to buy or sell goods to this kind of arbitrary value feels really unfair during gameplay. Of course, it makes the game even easier for top power. So when you get stronger not only because you are stronger, you get stronger because your economy, there is a very strong reinforcing effect. You get to the score 1. It means that your factories can buy whatever they need and they can sell whatever they need, and you get this first place for a really long time. You are reinforcing your position at this first place. But when you are at the lower location, at the lower score, your position, you can't really expand your industry, because your industry can buy things from the other nations, and your industry can't sell things to the other nations. So you can't really get away from this kind of situation without increasing your score in arbitrary way, hiring a lot of ships with high score, or maybe spamming prestige tags and so on, which makes the whole thing, well, not really immersive. You can just play the game normally and get a working economy. What Alice does in the first iteration of Alice is the following. It changes this kind of thing into a bit more different thing. So if you have a certain supplied amount on the market, and we have demand. We don't really have rank influencing supply and demand distribution in this case. We do the following thing. We just distribute all supply among all demanding agents in fair way. So it's exactly the formula which we were talking about a bit before. So instead of calculating demand satisfaction per nation, we calculate demand satisfaction per market. And at first, there was one market, the world market, and it made a lot of things much more uniform and more reliant on the actual situation on the market. So if you have one supplied unit and you have demanded 2 units of the entire world market, you have demand satisfaction of half, 50%. And all these nations have the same demand satisfaction, well, modulo their national market in the first iteration of the Alice economy. Everyone gets the same amount. So if you have expanded your demand as a top nation, you are not going to, well, just steal all these goods supplied by other nations into your factories. You will compete for them in a fair way. Well, of course, sometimes this fairness is not really good because the world is not fair. Some nations bear more strength than other nations, and this is what have created a need for further additions like multiple markets per nation, working tariffs, trade routes, and so on. Basically, this mechanism of supply-demand distribution created a need for more elaborate mechanics of markets, for more markets. But it's another topic. For now, we are going to discuss supply and demand themselves, assuming that we have a single market. Trade is a bit different topic. Okay, so how we work with supply and demand in Alice in general, in a more precise way. We have established the following definition. Supply is a promise. It's a promise to sell commodities. To sell commodity. And demand is a promise to buy commodity. It forms the theoretical foundation of supply and demand in Alice. It's a bit different from, well, Victoria 2 supply and demand because there you have you are producing a certain, well, amounts of goods, right? You are trying to consume a certain amount of goods, and these values are kind of they explain how many goods were actually produced or how many goods were actually demanded in a more, well, how to say it, in a more strict way, I guess, because there are actual amounts of supplied goods, there are actual amounts of demanded goods, but this model, again, it has actual goods, it has actual supply and demand, it's just defined in a bit more, let's say, unusual way. To make these things more theoretically easier to work with theoretically on theoretical level. So every producer, every consumer promises to the market that it will sell a certain amount of commodity and it will buy a certain amount of commodity. It allows to calculate the promises of all participants in the market. Suppose that we know that we have supplied a certain amount of goods, or we have demanded a certain amount of goods. Let's start with supply. We know that there was a promise to supply. For example, it's equal to PS0. Then we calculate and we have a certain, satisfaction of demand, which was, and there are actually two values. Let's say like this. There is a probability to buy goods, actual probability, to buy. Let's call it actual probability to buy. There is actual probability to sell. And there are, when there are actual probabilities, it means that there are some other probabilities. We call them expected probability. To buy. And we have expected probability to sell. So we have all these values. Currently, the only values which actually matter for the demand calculation and for supply calculation of the next day are these values. Right, we need to calculate these values. So what we are doing is the following. We know that every producer attempts to produce and supply a certain amount. So what we are doing is the following. Producers, step 1. Producers state promises. Well, let's say in a more simple way. Producers promise to buy promised demand 0, 1. Then producers promise, let's just say it's not producers, agents, a more general way, because not every consumer is a producer. It's easier to talk about it in a more general way. Agents promise to sell a certain amount, and to calculate this amount, we are using a value of how many goods they were actually able to buy the previous day. Actual probability to buy fits into this amount because we assume that they want to produce a certain amount of goods And to produce this amount of goods, they need to know how many inputs they were able to buy. And this is essentially this value. So this value, it kind of depends on the previous day supply and demand, right? This value doesn't really depend on it. It depends on the current production volumes of producers. So now we have actual promises to sell, which depends on actually produced amount. We have promises to buy. These promises are not really empty promises. They are guaranteed by market to be executed always. And it was a common source of bugs when we generated a promise to buy something, generated demand, but then just decided to, not buy the thing. It was leading to a certain weird effects. So it's a source of errors which you have to, if you want to contribute to Alice, you want to make sure that you always act on these promises. Now we have this provides us with actually produced amount. Then we match PS1 with PD1. It provides us with how many goods we were actually able to buy, because we have a certain promise of purchases, we have a certain promise of sales. We can calculate what was the probability to actually buy something, or probability to actually sell something. It allows us to calculate APB0, APS1, APB1, APS1, and we update with these values expected values, which are used in a different context, but it's very important to not forget about them. Okay. And that's all. That's all economy update of promise of generation of supply and demand, because now we have these values. And now we can actually calculate how many goods were actually bought or sold. So the next step 4, we use these values to calculate actual production. It's very simple. It's just equal to promised demand multiplied by actual probability to buy. This value fits into different things. For example, this allows us to calculate profits, which could be negative or positive. And we can calculate something which we call refund, because, for example, imagine that we have demanded a certain amount of goods. It's usually easier to use this step and reserve some money. Reserve money on this promise. And then this reserved money, use this probability to actually buy something to calculate refund. How many? So we have reserved certain money because we promised to buy something, and we reserve the money which we promised to spend. And now the game can refund us this money, a certain amount. So, for example, if we promise to buy 10 units of iron, and there was no iron, actual probability to buy was equal to 0, then we were not able to buy anything. It means that the game refunds us the full amount of reserved money. But there is still a certain amount of demand, because we have promised that we will buy something, and the merchants will see that local supply is 0, local demand is 10, and they will raise the prices to invite more production, and so on. This is why it's important to distinguish, well, demand and consumption, right? It's essentially this difference. And we reserve money for demand, and then we actually spend this reserved money according to consumption. And the rest of the money, which we are not able to spend, are returned back to the consumers, which were not able to actually buy things. So this is kind of the entire update of supply and demand in a single market. Again, it ignores the fact that Alice has multiple markets in every state instance, in every area. But there are a few questions still. Okay, there is a certain amount of profit, right? But sometimes this profit could be negative, right? And who gets the negative profit? Right? Because usually, if the profit is negative, it means that someone should suffer the losses. We try to assume that POPs can't have negative values in their savings, and we can't really decrease production to 0 the moment we have 0 profits or negative profits, because it will lead to instability, a lot of instability. We want essentially producers to be able to take a certain amount of debt. How does it happen? Depends on the exact consumer, the exact producer, but let's consider just a factory. In general, so we have a certain price. Let's say price P. We have a certain demand, promised demand. We have promised supply. We have all these values: actual probability to buy, actual probability to sell, and local merchants. What are they doing? What do they actually get from all these trades? We know that in total we have spent promised demand multiplied by actual probability to buy. It is how much money all the agents have spent. There is, and multiplied by price, of course, there is a total earnings. So there is a price multiplied by promised supply multiplied by actual probability to sell, total earnings. And sometimes, well, usually these values assume that these values are equal. So total spending is equal to total earning in terms of purchases. This is the main property of these values. You want to calculate them in such a way so these values are equal. But what does happen when, for example, when promised demand is larger than promised supply, then prices go up, right? Otherwise, there is a situation when promised supply is larger than promised demand, and we have excess goods. Then prices go down, and who gets all these goods which were overproduced? We assume that they are owned by merchants, by local merchants, which are actually local factory owners, and we have stockpiles go up. This is essentially what does happen in more details for merchants. So local merchants essentially lose nothing, but sometimes they get stockpile, which they are able to sell a bit later, maybe at a different price. And what does happen with individual agents? For example, we have a factory. It promised to buy, for example, promise to buy 1 unit of coal. And it has a promise to sell 1 unit of cement, which will be consumed by pops, eaten with their grain and cattle breakfast. And what is the profit of the factory is calculated like this. We have, for example, so the profit is equal to 1 multiplied by price of coal, so with a sign minus, it is their expense, and then we are selling actually the cement, so we get 1 unit of price, 1 multiplied by price of cement, and we multiply it as the actual probability to sell cement. This is our profit if we were able to actually buy everything, right? But then we should multiply it by actually how many goods we were actually able to buy, how much coal we were able to buy. So it depends on actual ability to buy coal. If you're unable to buy coal, of course there will be zero profits. Well, we can assume that there are no workers. Workers have wages, and it is again another topic. Profit ignoring wages. So, and it's possible that profit could be lower than 0. Factory could have a certain amount of monetary reserves, right? But it's a lot of data to track. So in Alice, we actually aggregate all these things. We have a thing called total factory balance. And this total factory balance accumulates all profits which were accumulated during a certain period of time. This total factory balance accumulates this profit from all factories, and then it distributes this to, if this balance is positive, it provides money to POPs, to owners of the factories. But sometimes this balance can be negative. It just does nothing. It accumulates the negative amount of money. And sometimes people think, well, this is confusing. How is it possible that balance can be negative? But actually, this balance is not really negative, because if we were unable to, if we were not profitable, it still means that total spending is equal to total earning. It just means that we are indebted to someone. It means we have paid more than we have earned. And a certain amount of this payment, so for example, it is how much we have earned amount, and we have a certain spent amount. Okay, so usually on an intuitive level, we should not be able to spend more than we earn, right? But in the economy world, you usually able to spend more than you actually earn by taking loans, debts, by making some promises, not actually spending this money. So this is kind of a hard spending. So we have earned some money, we are spending them. This part is clear, right? And this is a value which was not supported by hard cash. And this value is the source of being in debt. So this is we pay via debt. It means we are not actually spending any money, but we promise that eventually this money will be paid. Or maybe they will not be paid, but it still will be tracked. It means that our profit, our total profit, is essentially equal to minus debt in this case. Well, if profit is lower than 0, then we have a debt. Debt equal to minus profit. Exactly this value. And game And when we have a negative balance of factories, it means that we currently track their debt. How much money they have promised to actually pay. Pay to who? Who owns this debt? Who is the target of this debt? Well, Alice assumes that this debt is targeted toward local market. So local merchants. It is not a national bank. It is not a subject for, let's say, any kind of a percentage of increasing debt. It doesn't have interest or anything like this. It's just a promise to pay later. We assume that we pay now, someone else gets money, promised money, which they are able to spend, and we get a certain amount of debt, which tracks how much money we actually, well, essentially insert into the economy. It means that in Alice, money are not equal to gold, right? They include both the state of being in debt, the state of spending some promised money. Someone can pay you and get a certain amount of debt. Then you can use this money to pay someone else and someone else and someone else. To be really rigorous and to have an actually, well, extremely solid simulation, one could track who is indebted to who, track all these relationships. And then we could have a certain graph like factory, like you have a market, you have a factory, there is a debt, certain debt, market is indebted to someone else, another factory, there is certain debt. Well, maybe factory is indebted to workers. It paid them with promises of payment. These workers have, well, someone is indebted to workers again, another thing, and this is another thing, debt. And there could be a really complex chain of debt. Sometimes there could be like in a more general simulation, there could be, for example, loops of debt. But what we're actually doing is we are resolving all this debt in the, how they usually say, in the transitive way. So we have a market, a local market, or let's better say something entity, a certain debt entity, a certain entity. And when a certain balance is negative, it is indebted. It means that this entity, this balance, is currently in debt to this certain entity. Let's call it, for example, I'm not sure how to, there is no good name, but let's say it is a God bank. It is a certain entity which owns all debt. And if some balance is larger than zero, it means that this certain entity is indebted to this balance. So one could even say that all money is debt in our simulation, Alice simulation. And we don't have chains like this. These chains are impossible. All debt is tracked relatively to this certain God bank. All money is debt. Either if we have negative amount of money, it means that we are indebted to the God bank. If we have a positive amount of money, it means that the God bank is indebted to us. And this allows us to track all debts without any kind of, graphs of being of relationship or being in debt. It's actually a cool thing. It's literally the coolest thing ever. Tracking all these debt relationships and somehow updating the simulation, but it's expensive. On the scale of the Alice, it's impossible to do it in a really performant way. So instead, we are tracking money as a debt toward or from the God bank, essentially resolving all these chains into a simple graph, which has agents which are indebted to the God bank and agents which are on the opposite, have some money they got from the God bank. The God bank is indebted to them. Actually, one could make a game without having any sources of money like gold mines or minting and so on. You could have a simulation where the sum of all money is zero. Alright, all money is debt, and if you resolve all debt, you get into position where there are no money. It's possible to make a game like this, but it is usually confusing for people. People usually don't deal well with negative numbers. Sometimes they don't even understand what negative numbers are. And for this reason, we try to provide a certain amount of baseline money. There are gold mines, starting treasury, and so on, POPs money, which are always positive, which lead to the situation that in general balance is positive. Even if we have a lot of this kind of debt in the system. It allows us to obscure the details and make it look like, well, it's normal spendings. Everyone has a certain amount of money which they are able to spend, but sometimes it's possible to get into the negative balance, especially if factories are not gaining any money for a long period of time due to some blockade, embargo, economic crisis, and so on. So factories can get indebted really badly, but it's not something weird. You should understand that it just means that these factories have a debt. It's not a game like breaking down. It's just a normal case of certain agents taking debts or paying these promises to avoid the closing down, because the alternative to having negative amount of money is just economy breaking down at every single crisis, which is not good. And it's not fun to play games like this. So I hope that I have managed to explain the basic details of supply, demand, and how they interact with the monetary balance of the game. I hope that, well, that's all.